So let's talk about solving projectile motion problems. Keep in mind, we're talking projectiles here. We're talking about something that is shot or thrown through the air, not a rocket pushing itself through the air or an airplane, but something that is just shot or thrown. So here we've got this situation. Somebody throwing a ball. The key here is the ball is thrown horizontally. That's an important term. Horizontal is perfectly level with the ground. It's not up and down at all. And we're given an initial velocity. And we're also told how high the pitcher's hand is off the ground. Now, I included a picture here because with these problems, it's going to be very helpful for you to draw a quick sketch of what's going on. You don't have to draw a person. You can draw a stick person. But I'm going to go ahead and label what I've got here. I know that this right here, this height is 2.89 meters. I'm sorry, that's pretty ugly. 2.89 meters, because that's what I'm told here. I'm also given a velocity of 26 meters per second. Okay, well, if I'm throwing it horizontally, that means it's only going this way at first. I'm not throwing it up and I'm not throwing it down. So that means the initial velocity in this case, it's being thrown this way. That's an x direction. So my velocity in the x direction, at least my initial, is 26 meters per second. And I know that velocity that I'm giving is all an x velocity because this is being thrown horizontal. It's not being thrown in the y at all. It's only being thrown in the x. So will this ball be in one-dimensional or two-dimensional motion? Explain. Well, it's going to be 2D motion. Why? Because the ball will move in x and y at the same time. As soon as this person throws the ball, you know it's going to start to fall to the ground because gravity is going to work. Now it's still moving this way as it falls to the ground. Well, that's moving in x and y simultaneously or at the same time. That's two-dimensional motion. Okay. Does the ball have an initial velocity in the y direction? In other words, did the person throw the ball up or down at all? Did the person throw this ball in the y dimension? The answer is no. There was no initial y velocity, so my velocity in the y direction initially is 0. So that's what it starts at because the person doesn't throw it with a velocity up or down. But will that velocity change? Well, that's an acceleration. Does the ball have an acceleration in the y direction? Is its velocity going to change in y? Well, it's starting off at 0, and you know it's going to move towards the ground. It's going to have a velocity as it hits the ground. So the obvious answer here is yes, the velocity is going to change. It's going to be going some speed in the y when it hits the ground because it's going to go down and be moving down as it hits the ground. So does it have an acceleration in the y direction? It must. Because it started at 0 and it doesn't end at 0, it changed. So yes, there is an acceleration in the y. Something is changing the ball's motion in the up and down dimension of motion. Well, what's causing that acceleration? What causes things to change their motion in the y dimension? That's gravity. And this is why we did free fall problems when we did. Because now this is an object that is in free fall, and we know that the acceleration due to gravity in a free fall problem is that. Okay. Now, does the ball have an acceleration in the x direction? So think about the moment the ball leaves the person's hand. Is there anything that causes it to speed up or slow down this way? Well, it's not gravity, because gravity works this direction. Gravity doesn't make a projectile speed up or slow down in the x. There is nothing speeding up or slowing the ball down in the x direction. If you think about it, what would cause the ball to accelerate in the x direction? Nothing. So we have no x acceleration, because there's nothing pushing or pulling on the ball in the x direction that's going to cause it to change its motion. The y, yeah, the y's got gravity, but the x dimension does not. Okay. How far will the ball move in the y direction as a projectile? Well, keep in mind, a projectile is anything shot or thrown through the air. That means it's going through the air. So long as it's in the air, it's a projectile. The moment it gets here and it hits the ground, it stops being a projectile because it's not moving through the air anymore. How far is that in this equation? Well, person's hand releases the ball here. The ground is here. The ball's going to move 2.89 meters in the y dimension, because that's how high it was when it started. It's going to finish down here at the ground, which is, say, our 0 level. It's going to move 2. It's not like the ball's going to get to here and stop, and hover like half a meter above the ground. It's going to move 2.89 meters in the y. Now, we got a distance. Let's see if we can figure out which kinematic equation we can use to calculate. Notice this is a math problem here. This is a formula problem. How long it will take the ball to move to the ground. You just said it's going to move 2.89 meters. How long is that going to take? The how long is a time. So what do I know? See, I got a distance. I got a time. Let's look at our kinematic equations. I'm trying to find the time. I know the acceleration due to gravity. I know that initially in the y it was 0. I don't know its final speed in y though. So I got two unknowns here. Let's go to this formula. Well, that's got a time in it. Once again, I know the initial. I don't know the final velocity. I do know the acceleration is 9.8, but I got two unknowns once again. Let's check out this kinematic equation. Do I know the distance it moves? Yeah, it's 2.89. Do I know the acceleration? Well, it's caused by gravity. It's 9.81 meters per second squared. Do I know the initial velocity? Yeah, the initial velocity was 0. So I can use this formula here. Distance, 2.89 meters. And we're going to go 1/2. The A is the negative 9.81 meters per second squared. T squared. Now this part of my equation is going to drop off because it's going to be 0 times t. Why 0? Because the initial velocity in the y was 0, because the person didn't throw the ball up or down at all. So that drops off, and I calculate this, and I get a time of 0.768 seconds. So not even a second, which kind of makes sense because, this is somebody dropping a ball that they might be throwing. It's not going to take very long to hit the ground. Okay. Thinking question. When does the ball stop being a projectile? When it hits the ground. As soon as it hits the ground over here, it is not a projectile anymore. So I folded the paper in half so we can still see this diagram while we're answering these questions. What is the initial velocity of the ball in the x direction? Well, we know the person threw it horizontally, or all in x, at 26.0 meters per second. That's how fast the ball is going that way when the person releases the ball from their hand. What's the final velocity? So I know you might think, well, we could maybe take a formula out here and we could do some math, we could calculate, but we don't really have to, because what was the acceleration in the x? There wasn't any. So whatever the ball starts at in the x is whatever it finishes, because there's nothing changing the velocity of the ball in the x direction. It's being changed in y because of gravity. Going this way, the ball stays the same speed. So its final velocity is 26.0 meters per second that direction. So what is the time the ball is moving in the x direction as a projectile? Well, remember, right here at this point, it stops being a projectile because it has dropped all the way to the ground. And we did a previous problem. We figured out this time to drop. The time to cover that y is 0.768 seconds. Now, the whole time it's dropping, it's also covering a distance in the x. Well, as soon as that time is up, as soon as the time it hits the ground, it stops covering any more distance in the x direction because it hits the ground. It stops. So the time in the x is always the same as the time in the y because there is only one time. So the time, that's pretty easy. I didn't even have to do any math there. Now, how far does the ball move in the x direction? What is dx? Remember, the dx also has a name. It is called the range. So the question could be worded, what is the range of the ball, or how far does it move in the x dimension? Well, this is going to be a pretty easy kinematic equation. I want a distance. Let's got distance. Do I know the acceleration of the ball in x? Yeah, 0. That'll be convenient because that part right there will cancel out. Do I know the initial velocity of the ball in the x? Yeah, it's 26. Do I know the time it's moving in the x? Yeah, it's 0.768 seconds. So we got d equals 1/2 at squared. I might even write x there. Let me keep them straight. Well, 1/2 0 t squared, doesn't matter. This is 26. The time is 0.768. So the distance, when we do this math, the distance in the x direction works out to be about 20 meters. So this person at this height, releasing the ball horizontally with that speed, the ball is going to wind up 20 meters that direction. Okay. Now, something else we haven't figured out. When the ball hits the ground, it now has a y velocity. It strikes the ground with a certain velocity. What was that velocity? So let's see. How can we figure the speed of the ball in the y direction now when it hits the ground? Well, what do we know about the y? We know its starting speed is 0. We want to know what this is. We know how far it falls. We know the time it falls. So let's go to our kinematic equations and see, well, what's a formula that could help me calculate the final speed in the y dimension? Do I know the acceleration of the ball in y? Yeah, it's 9.81. I want to know its final speed. Do I know its initial speed? Yeah, it was 0. Do I know the time it was moving in the y? Yeah, it was at 0.768. So I can use this formula here. It's got the VF in the y. I'm going to say minus 0 because I know the initial, in this case, was 0 because the ball wasn't thrown up or down at all. We multiply these two, and we're going to get our answer. When we do this math, we get a velocity final in the y dimension to be 7.53 meters per second. Oh, wait a minute. I left something off. So negative times a positive, that's negative. Is that important? Yes, because we know that these positive and negative signs indicate direction for us. And the ball is certainly going in what we call the negative direction with that velocity when it hits the ground. Okay, so that's your introduction to projectile motion problems. I would highly suggest that you keep this sheet handy and that you can reference it when you need to solve these types of problems in your homework set.